chemicals in the pre-treatment section. So the two cylinders contains chemicals which include the gravel, sand, charcoal, resins, and other chemicals to treat the iron precisely, and then it also helps to treat the salt. But the salt will be majorly treated. The remaining treatment that will not be handled by the treatment section, the reverse osmosis, through a salt desalination membrane that is already installed, will help to make sure that after this installation, the water they are going to be using will even pass tests for bottled water business or saturated water business. They won't notice any salt again, they won't notice any iron again. So that is the essence of the seal or the pouring now. So that's about this section. So when we finish pouring this chemical, we'll seal and then we'll connect. Like I said, what we're doing here is the treatment section, which you can see. This is a treatment filtration system. This alone is also under treatment filtration system, like I said before. So everything here is treatment and purification system. That is why this is better than this other conventional treatment system they installed here before. Because this one contains only some chemicals which they poured in, which include the gravel, the sand, charcoal, and probably some resins. But here, after pouring those chemicals here, and in which we included resins for salt and iron, then this one alone can serve as a treatment system, even assuming it doesn't have salts. Then this cap alone can serve as a treatment system for any water system. You're welcome to the site again. We are at the concluding this installation, and we need to understand what we have really done in installing reverse osmosis in this place. This is the Amingoo Gas and Oil Limited at Obekaba in in Tezaba, Ebonyi State. And I am Engineer Dr. Opoke Sunday Andrew, Director and Founder of Kudu Engineering Academy and the CEO of Kudu Engineering Consult Limited. When we came to this place, we discovered that they have a borehole here that is contaminated with salt and iron. As you can see the plant there, you can see the level of damage that is already been caused because of the appearance of iron here. There's an overhead tank the other way that was already, that had collapsed due to the effect of the salt. So this water has high concentration of salt and iron. And because of this, we have come to install reverse osmosis. What is reverse osmosis? It's a water treatment system that has capacity to treat any kind of pollution or pollutant in water, especially groundwater. It has the capacity to treat the physical properties of water, the chemical properties of water, and the biological properties of water. Now, let's look at what we have done here. In the reverse osmosis system, we have a pretreatment system, which you can see that is working right now. This is called the pretreatment system. The idea of a pretreatment system is the water that comes from the borehole will pass through this treatment system. The treatment system actually, but it treats water, any kind of impurities in water. But what we are trying to solve is not just impurities. It's not just the taste or odor or the physical properties of the water. But we're looking at the chemical pollution caused by salt and iron. So, and then that is why we brought to this reverse osmosis. So, like I said, we look at the components of the reverse osmosis. This is like the control box. This is a controlling system. This control system works with two pumps. This is called vertical pumps. This is called the surface pump. So the work of this is to enable these two pumps to work. Now here is a permeable membrane. All that we've been talking about will be treated at this point. The water, you can see the water is already clean, but we cannot guarantee that it's completely treated now, that the salt has been removed until it has passed through this permeable membrane. This permeable membrane can now remove the salt and iron. This one can remove every other thing in the water, including iron, but to an extent. So, but at least it will remove the taste, it will remove the odor, it will remove every other physical property that is like a pollution onto this water. But that is not all. If the water didn't pass through this permeable membrane, you cannot guarantee that the salt has been removed. And the mistake many people make when they even use this system is that they don't know that everything you want to treat is like someone that is sick. You need to come and take the water to lab. Like we came, we took the water to lab, and we were able to see the concentration factor, the degree of concentration of the salt and the iron. So we now know that the type of permeable membrane we're going to use must be specifically for salt and iron. There are other permeable membranes that can be for general water treatment, like vitro and the rest of them. So, but this particular membrane like that is designed purely for salt and iron. So, what we're saying, our colleagues who also engage with this always know that what you want to treat, you must do laboratory analysis to know what you want to treat, so that you'll be able to know the kind of permeable membrane you will use to treat what you want to treat. Now, when the water passes through the permeable membrane, it will come to another filter here. So in case if there is anything that was not removed from the treatment system, from this, at this point it will be trapped with this filter. So after this filter, then it's assumed the whole thing is treated. The water goes out from here. So the water that goes out from here is now free of salt and iron, free from any other pollution or contamination of the water. So, but let's get back to this. Now here As this, you need to understand how to use the pretreatment system. We have identified it has backwash, it has this one, it has filter. So whenever this thing faces, means that's the way it's working. So at this point, this is backwash, and that's what is happening now. When we finish backwashing this, like you can see that the water was dirty before, it's now clean. So when we now turn off this, the water will start entering to this one. This one will also remove every dirt in this water before we switch it onto this one. So let's see how it goes. We are going to transfer this water into this one now, so that this one will also do its own work. So then we will now transfer this one to backwash. Okay? Okay, this is backwash already. So we are done with this, it's clean already. Okay. So like we were talking before, treating salt is a difficult technology, because salt is permeable, is soluble. Because it's soluble, all the chemical content of heavy metals like lead, zinc, mercury, they are all soluble in water. So it mixes with the water. If you are treating it, you must engage different stages of treatment. Like why this wouldn't have been necessary if we are just treating ordinary water, or this wouldn't have even been necessary if we are treating ordinary water. But these two treatment systems with the reverse osmosis is perfect combination. So what we are seeing now is the pretreatment section, which inside the two cylinders, there are chemicals that we put inside. They'll be able to treat everything about the physical properties of this water. But the chemical properties of the water will be treated by the reverse osmosis. What's the chemical property? Like I said, the heavy metals that are soluble in the water that may have escaped from this tube has to be treated in this one. So at this stage, you can see the tube is working. All we need is for them, when it clears completely, then we are sure they will transfer the water into the system. When we transfer it to the system, then the water will go through the permeable membrane, and then the clean, treated water can go through the other way. This reverse osmosis has the capacity to even suck away water. There's no kind of water I cannot treat. No matter how polluted the water is, the reverse osmosis has capacity to treat it. Reverse osmosis water treatment system is the best in the whole world for today. In Florida and some other countries where they recycle water, they suck away, treat other water. You won't even know, because it treats everything about it. So we are glad that we have come to solve this problem. So when we come to transmit the water to the reverse osmosis, we now see the difference between reverse osmosis and any other water treatment system. So that, like I said before, these two would have been enough if it's just any physical property. But it's not enough now. We need this one, because what we're treating is chemical content and contamination of the water. So thank you very much for being part of this exercise, and then we welcome you. If you have salt and water, salt and iron, or any kind of water pollution or contamination in your water, the best way to treat it is reverse osmosis. And the best way to treat every kind of chemical contamination of water is through reverse osmosis. Like I said, reverse osmosis is the best in the whole world. It comes in capacities. So this is 500 liters per hour, 1,000 liters per hour, 2,000 liters per hour. So it comes in capacities. So as it is, you can use this water now to do your sachet water, even bottled water. The water that will come through this system will be far better than the water you have been drinking around here, including the bottle or the sachet water you have been drinking around here. So you'll be so glad when this process would have been completed. And thank you very much for being part of it. It's still your friend and director, Dr. Opoke Sunday Engr, on site. You're welcome, sir. That's it.
This video was brought to you by Curtis Engineering Academy in partnership with Curtis Engineering Consults Limited.